Good. Well, thank you very much for your very kind invitation to speak this evening, and I'm going to try in the time available to, if you like, open up a new front on the climate change issues, which is your prime concern. And I'm going to do that by talking a little bit about the second of the great challenges of our time, biodiversity and biodiversity loss, and a little bit about natural capital, and then try to bring the two problems together. I should say, by way of disclaimer at the beginning, I am chairman of the Natural Capital Committee and have been chairman of the Natural Capital Committee since 2012, and it is the first Natural Capital Committee in the world. Everything I say is my own views and not those of my committee. If one day you have the privilege of running and chairing official committee, you'll find that it's extremely important to make sure that you distinguish between your own views and those that you can get a committee to agree to. So these are my own views. My agenda this evening, is this going to, it's this one, isn't it, you want me to use? Let's try this. Yes, good. Technology works. I did my thesis on a typewriter with Tipex and carbon paper in a world you couldn't possibly imagine. So what I want to do is, first of all, set out these two twin challenges in their perspectives and bring them together, and then talk about the core natural capital objectives and the 2-degree target that people have for climate change. And then I'm going to get you to think about these things from a natural capital direction and get you to think about these things from a climate change direction, and then I'm going to try and bring the two things together. And I'll explain in the fallout from that how carbon fits into the 25-year natural environment plan, which has recently been announced by the Prime Minister and Michael Gove, the Secretary of State for Defra, and is the proposal and plan that we in the Natural Capital Committee put together. So that's my agenda. But first of all, let me just do a little bit of scene setting. So imagine for a moment that you are my age. Okay, I know that's a long thought away for many of you in this room, but think forward several decades into the future and think what mid-century this planet is going to look like, and think about where the issues that you're interested in fit into that framework. Because although we're all focused on what we can do today, it's extremely important to see what's coming and what that framework looks like and what it'll look like to you and your children to try and deal with it. So there are some things we've got some pretty good knowledge about between now and then. We know that the carbon concentrations have gone through 400 parts per million. And we know there's not a single blip in the increase of those carbon concentrations. There's stuff about man-made emissions going down or not in recent years, but in terms of the ultimate measure, the concentration of CO2 in the atmosphere, there's not a blip in sight. We also know that the stuff that people are doing now is going to carry on that emissions growth. So for all the lovely words about how wonderful China is about addressing climate change, it added 45 gigawatts of new coal last year. That's not quite the entire installed capacity of the UK, which it was putting in new coal per annum until very recently, but it's most of it. We know coal burns rising across the board. We know what the projections of the oil companies are, that there will be a very substantial oil burn mid-century, which is entirely incompatible with the 2-degree warming target. So we know that provided the science is robust, that the path of global warming by mid-century will have gone quite a lot further than it currently has reached. It is going to go on doing that. And none of the existing policies in place have a hope in hell of changing that projection very much. I'll come on to what you really do need to do if you really do want to address climate change. And my latest book, which is a little bit of an advert, coming out in paperback in a couple of weeks on the burnout, is about how the end game of fossil fuels actually works out. But that, you know, is what the world would be like when you're more like my age than you're like your age. The second thing you know about that world is there'll probably be something like 9 billion people on the planet, or even 10 billion people. You'll certainly be well on the way towards it. The path from 2 billion people in 1900 to 7 billion people in 2000 continues upwards. And the most recent evidence from the looking at demographics suggests that, in particular, Africa is not going through the demographic transition, which leads people to optimistically think the world population is going to bottom out or top out at 9 billion. It may well go to 10 or 12 billion, and even then there's no guarantee that there is some automatic demographic transition that people will all start having less children as time goes on. So you know there's going to be a lot more people. What's more, you could be reasonably certain that global economic growth measured in GDP terms between now and mid-century will be at least 3% per annum. It's currently 4 to 5% per annum. The fastest growing economy in the world is India, which is in the 6 to 7 to 8% increase. China, of course, has fallen back, having been growing at 10% per annum for 2 to 3 decades. So basically, I'll extrapolate it to 210 because I can remember the numbers. Okay? If you just do the cumulative numbers of 2 to 3% growth for the world economy from now till 2100, then on even the most pessimistic framework, people will be, in aggregate, 16 times wealthier than they are today. Now, of course, they may not spend all of that 16 times higher, but I ask you to think through what you would do if you had 16 times your expected income from, say, your first or second job when you're in your late 20s. 16 times more money. What would you spend it on? What would you consume? Now, you in the room might do some really wonderful things with that. But you're not, because you're here this evening and you're pursuing climate change at this time of the evening, you're not the average person in the population. Would you take more holidays? Would you go to the Seychelles more often? Would you have 2 houses or would you have 3 houses? This is a consumption path on which the planet is directed. Now, of course, GDP per head will be growing slightly less because there'll be more heads, but a lot more consumption will be taking place on this planet in the mid-years of this century, and certainly at the end, than now, with these extra people. And in this world that we're describing going forward, on current projections, and here, when you're a biologist, other people know these things much better than I do, we don't really know almost orders of magnitude how many species there are on the planet, but O.E. Wilson and others have suggested that on current trends we might eliminate half the species on the planet by the end of the century. That's not your nice tiger or your emblematic polar bear. That is whole ecosystems being affected and taking out the effects of that. Now, I suspect that many of you will agree there aren't many problems confronting this planet and the people on it that are bigger than those biodiversity losses, that climate change, and the attempt to address both of them against economic growth and against higher populations through time. That is an enormous challenge, and if you were realistic, as opposed to, I hope, at least slightly idealistic, you'd realise that it's a fairly hopeless task to try to stop a lot of that environmental damage taking place. But we must try. And we must think through how rationally and practically to address these problems, given not the world we'd like it to be, but the world that's actually likely to be the one we have to confront to deal with these problems. So, we have to deal with these two in a world in which, this is extremely crude, but it's meant to illustrate just a crude point, in which most people see the increase in GDP as a good thing. And what's more, they see, you could take this back to 1950 or even 1900, they see the increase in GDP being pretty closely matched by the decline of biodiversity. Georgina Mason, others in the environmental world have mapped these things much more precisely. But so far, most people think, well, we've got by pretty well by destroying nature. Indeed, much of economic activity has been about fighting back nature, cutting back the forests, extracting the resources, stemming the flows of rivers, building the dams, and generally bringing land into agrochemical cultivation. So we've done pretty well trashing the environment. We've got the consumption that you enjoy today as a price of pushing back the natural environment around us. So when you say, look, you know, destroying biodiversity, damaging our natural environment is going to damage your prospects, so you appeal to people's self-interest, the answer is, so far, we've got by pretty well without. And that's how most people see it. And that's why, if you look in public policy, in the main drift of public policy, the environment is very low down the agenda. If you listen to the rhetoric in this country, people are concerned with jobs, austerity, welfare, housing, transport, health, education. Oh, somewhere down the bottom is the environment. And we're in an exceptional time at the moment in which we have a very powerful Secretary of State, but it's usually right at the bottom of the cabinet pecking order. And it's true if you look right across the developed world. In America, it's worse still. The President actually thinks it's a positively bad thing to be enhancing the environment and protecting the climate. The second thing is that these two things are pretty well correlated too. And there's a lot of nonsense written about the idea we've broken the link between economic growth and carbon emissions. If only. And if we think about measuring carbon emissions properly, we will observe that the emissions continue to go up, as does the GDP, on an almost linear line since 1990. There isn't a blip since Kyoto was agreed at all in the projection and growth path of that carbon emissions, and the GDP matches it quite carefully too. So does the coal burn as well. So we have to think about this as to whether it's basically that we're living beyond our means and we have to stop GDP going up in order to stop the damage to the environment, or we have a framework in which economic growth and environmental protection are mutually consistent provided you measure economic growth properly. And there's a huge debate amongst environmentalists about what constitutes legitimate economic growth, and that's where the natural capital story comes into the fray. Okay? So concentrating on the biodiversity side and the natural capital side, natural capital is just a set of, this is in economics terms, a set of assets which are like human capital, that's your education, your ideas, etc., etc., and man-made capital, like this building. And economic activity is not, as conventional neoclassical textbooks will put it, simply combining capital and labour. It's combining natural capital, human capital, physical capital, and of course labour, into a production function to produce outputs. Now the next point is, are all these factor inputs substitutable for each other? Or are there some constraints on substitution? And in addition, is there something special about natural assets which trumps or is more important or is crucial to the rest of the assets? Okay. So what most economists do, and I presume, how many economists have we got in the room? Mercifully few. Excellent. Okay. Most economists just assume that what economics is about just flexing the factor inputs to get output. So for example, people talk about robotics and they say, well, robotics are going to take the place of labour because robots are going to be cheaper than labour. It's just a substitution between the two. We can worry about the social consequences subsequently down the track. Well, that's exactly how they've thought about the environment. And that's what we've been doing in human history. We've been substituting the environment for buildings like this. You can go into the green belt around Oxford and see people substituting the green belt for houses. That's just a substitution. And the question about that is, first of all, is that a legitimate substitution to make? And the answer is sometimes it is and mostly it isn't. And then the second thing to say is, if you properly factor in the environmental constraints, do you get a different story about economic growth coming out the end? And this is where we make a second distinction in natural capital between renewables and non-renewables. And the term renewables doesn't mean windmills and solar panels. It means assets which nature gives us for free and will go on giving us for free forever, provided we don't over-deplete them. That's what a renewable means. It will go on renewing itself. The other kind of natural capital is non-renewable natural capital, which is stuff that nature gave us for free, but we can only use it once and that's the end of it. Now, in the non-natural capital, that's oil, gas, coal, minerals, etc. Right? Someone uses the stuff in the North Sea, someone spends the money, and then the next generation, you don't have the benefit, or you might think the disbenefit, of inheriting all that oil. Right? But if you go fishing in the North Sea for herrings, provided you don't take too many of them, there'll be herrings forever in the North Sea, and every subsequent generation can consume them. Okay, and I'll come on to a little bit about that in a moment. In the biodiversity world, in the natural capital world, the thing that really matters is the renewables. And what you must do is make sure you don't over-deplete them so that that stream of benefits of future generations is not extinguished. Okay, that's what extinction does, unless you really believe in genetic engineering on a really quite scarily dramatic way. You just eliminate those possibilities. So we worry about the renewables, and what I tried to do in my book on natural capital is build on something which the British government actually committed to, which is this thing under the 211 white paper, which was the British government said, we're going to be the first generation to leave the natural environment in a better state than we inherited it. Okay. Now, I'll just give you a little bit of background. This was in the David Cameron era, and Defra at this stage was, this was 5 Secretaries of State ago. I've been through 5 of them chairing this committee. Okay? This was a world in which Defra was given no legislation, was at the bottom of the pile, and they were allowed to have a white paper on the natural environment and a white paper on water, and that's it. So they came out with this paper on the natural environment, and you can tell how good a government document is by using a rule of thumb I use, which is the higher the ratio of pictures to text, the less content it has. Okay, so environmental things and climate change things lead themselves to pictures of kingfishers. They love kingfishers in natural capital, or windmills. They love those, or wind turbines when it comes to climate change issues. This has got lots of pictures in it, right? And it has a sort of bit at the beginning about putting the environment at the heart of the economy, and then it has virtually no substantive proposals, and at the bottom it says, classic kind of Sir Humphrey, oh, we'll set up a committee to think about it. Okay, that's the Natural Capital Committee. And most people would say, why bother? To me, what that says is, you committed to this, we're going to work out what you have to do to achieve that, and we're going to hold you to doing that, and that's the origin of the 25-year environment plan, which the Prime Minister announced in last month. So in my book on natural capital, what I try to do is work out what would have to be true for you to actually achieve not just halting the decline of the natural environment, but increasing it. Okay? And I invent 2 rules. A weak and a strong rule. The weak rule says that you must keep the level of natural capital constant. That begs the question of being able to measure it, set out the units, do the accounting, okay? And if you deplete your non-renewables, North Sea oil, etc., you must make compensation for that reduction. Okay? The strong rule says the same thing, but if you deplete natural resources like the North Sea, you must invest in increasing the renewable natural capital to compensate for it. Okay? Out of this drops, I won't have time this evening, the idea that when you're depleting the North Sea and pumping out all that oil, you should put the money in a sovereign wealth fund, but it actually should be a nature fund, because the depletion, the economic rents, should go to rebuilding your renewable natural capital. Okay? Now you can argue about those exact rules. You can argue whether they have a philosophical base. I would argue they do. An ethical base. Or you can argue whether they just happen to be pragmatic. We've done so much damage already that we're doing so much damage to the economy going forward. So you can either take either of those two. And none of this says that as a result you shouldn't be concerned about economic growth. Right? You just have to be very careful what economic growth is in this context of thinking about natural capital. So economic growth is ultimately driven by technical progress. And there's no evidence whatsoever that we're slowing down in the ability to push forward the technological frontier. Okay? So when I was doing what you were doing, maybe some of you, when I was doing my doctorate, I had an Olympus portable typewriter, and I had Tipp-Ex and carbon paper, and I can tell you it was hell to correct your draft. You couldn't make it up as you go along and switch the text around. There were no fax machines, no mobiles at all. Just imagine how you could live your life without a mobile. Okay? No laptops, no Word program, nothing that you are absolutely addicted to. Right? You couldn't function. In fact, the British economy couldn't function without those technologies. Now, to say I'm against economic growth, nobody is going to say I'm against the advance of technology in those senses. Similarly, when it comes to genetics, medical advances, etc., these things push out the envelope. Of course, not everything we discover is good, but there's no suggestion that the human race is going to stop that process. And because I have a mobile phone in my pocket, which is a more powerful computer than I could have envisaged when I was a student, that's great. That's a net increase in our capacity. That is economic growth. What isn't economic growth is running down natural assets, consuming the outcome, and simply assuming that makes you better. And that's what GDP measures. GDP is a dreadful measure of the performance and the ultimate economic growth of an economy, because it has no assets in it, no balance sheet, so you can deplete, for example, the North Sea, spend the revenue, and call that GDP and GDP growth. And that's exactly what my generation did. Okay. So in the Thatcher years, economic growth was a measly 1.7% peak to peak or trough to trough, but a chunk of that was simply using up the assets. It would be like a developing country chopping down its rainforest, flogging off the mahogany and saying that's income, therefore GDP's gone up. So what you have to do in this world is not be against growth. You have to be in favour of sustainable economic growth, and sustainable economic growth is asset-based, and it makes sure that you do the capital maintenance necessary to keep those assets intact, those natural assets intact, and then you can go on beyond that. I think you would conclude, if you did the analysis of what we're actually doing and the consumption levels we have at the moment, that we are living way beyond our means, that we're not on a sustainable consumption path, but once you move to a proper sustainable consumption path, it can grow through time. So the argument against growth is really to say we either empirically are not going to make technical progress, or that we shouldn't make technical progress. And I think that's wrong. But the argument that what we should be doing, saying, oh my God, we've got austerity going on. We've got to fight the cuts and get more public expenditure in order to get our consumption level up higher, in order to increase GDP growth. That begs the question of what the baseline is. We're happily piling on debt to the next generation. That's what we're doing. Trump's new tax plans and expenditure plans will drive the US deficit to 5 to 6% of GDP next year, probably. Okay? That is consumption today, for people today, paid for by people tomorrow. And that is not a legitimate argument. That's why I'm stunned at the relationship between those who are in favour of doing something about the damage to our environment and people who think that they're against austerity and they think we should increase public expenditure and general consumption levels now. You might want to rebalance the distribution between rich people and poor people's consumption, but the basic Keynesian project is to expand aggregate demand. And my response to that would be, why would you want consumption to go up even further when the current consumption level itself is already unsustainable? That's not an argument about growth, that's an argument about rebasing to an asset-based look at the way to do things rather than a consumption one. Now that's all about natural capital and the focus on natural capital, thinking about it, thinking about ecosystems, thinking about how to measure the units, thinking about how to monetize some of it, which offends lots of people, but if you don't measure something, usually it's given a default value in policy of 0. So it is quite important to have some numbers in the frame. That's a whole project. And you start to think about how you put together a 25-year plan and all those parts. Now that's one side of it. On the other side is the climate side. Now you probably won't agree with this, but what we have in the climate side is a target, 2%. Right? You say, why 2%? Why not naught? Why not minus 2%? Why not plus 3%? Why are you all campaigning, well, some of you all campaign, you're all interested in hitting the 2% target? My guess is the answer is because people think it's a feasible target or a stretch target you might actually achieve. But I struggle to find anyone who thinks that a 2-degree warming is the optimal climate. In fact, I struggle to think what the meaning of the word optimal climate could be. Is it where we were in the 19th century? Is it at 275 parts per million? Or is it when the climate was such that the Vikings could get to Iceland, Greenland and North America and grow grain in Greenland? Is that the optimal climate? Okay? We don't know. Indeed, it's not even an answerable question. So we don't have a theoretical basis for saying 2 degrees. We just have 2 degrees as something feasible. I'm not attacking the number, by the way. It's just saying what it is. It also has no ethical basis either. It's not ethically the right temperature increase. And the ethics of this, and many of you appreciate it, are rather complicated, because people in Northern Europe are probably going to get quite a lot better off as the climate warms, while quite a lot of people in developing countries are going to get worse off. Up to 2 degrees, it's probably the case that global GDP, I mentioned the word GDP again, but that number, global GDP will go up rather than go down as a result of the increase in temperature. That's what makes this problem so difficult from a public policy perspective. Things get better before they get worse. And why is that true? Well, nearly all the world's wealth is in the temperate zone. Okay? It's in Northern Europe, North America, China, etc. Okay? And in those countries, 2 degrees warmer means less heating, it means longer growing seasons, it means all sorts of things which will be beneficial to individuals in their lives and their lifestyles, given that they don't actually depend very much on the natural environment anyway. Okay? So, is it ethically the right number? Not really. Doesn't mean it's that some other number's better. It's again, we're just picking it for pragmatic reasons. And then empirically, Is it really empirically the right number to come to? Have we really worked out the marginal costs and marginal benefits of this number versus something else? No. In fact, I would argue there is no empirical basis for saying that 2 degrees is the optimal target for us to go for. The reason we're choosing 2 degrees is just because we want to stop that continuous upward growth in concentration, because that's linked to climate changes, and we work back from that and say, what's the best we can do? And that's exactly how that target emerged. And then at the Paris summit, and if it wasn't so tragic, it would be quite funny. At the Paris summit, so people go along and they say, let's make loads of pledges. Okay? We said they were going to be legally enforceable. That's what was agreed at Durban. We turn up, they're not going to be legally enforceable. Right? But we'll make some pledges. They don't add up to 2 degrees. So here's the bit. So we'll decide the target's 1.5. Where does that come from? Okay. Indeed, where do such top-down agreements get us in this overall framework? So, all you can say about the climate change side is we have a pragmatic target which reasonable people have persuaded reasonable people is something we should aspire to. But it's not necessarily the best target to go for. Now, the other thing I want to say about climate change is, compared with biodiversity and the natural environment more generally, it's really a simple problem. Okay? It's a small number of gases, and it doesn't matter where they're emitted from. Right? The absolute opposite is true of the biodiversity natural environment problem. It's a massive number of species and habitats and forms, and every location is different. Okay? The advantage on the environmental side is it means that you can make real changes here regardless of what anyone else does and improve the natural environment. You can try to reduce emissions in this country and make global warming a lot worse as a result. So in my Carbon Crunch book, I demonstrated pretty clearly that while we had been reducing carbon emissions from 1990 to 2005 by something like 15%, and that's what we measure in these Kyoto and Paris targets, we did in fact increase carbon consumption by 19%. So we've reduced carbon emissions in Britain by bearing down on the energy sector, and particularly the electricity sector. We've driven up the cost of energy, so we produced even the cement in China and shipped it back into Britain. Then we consumed the cement that had been made in China, the steel and everything else that we used to make in Lanvern, or the aluminium we used to make in Anglesey, and then we said, that doesn't count for our emissions, aren't we doing well? Okay? That's exactly what we did. In fact, if you look at Kyoto, I'm sorry, it makes me almost angry. Kyoto, Europeans go round telling us what a fantastic achievement this is. The only countries left in Kyoto were European countries. And the only reason that European countries could sign up to these things was because it was relatively straightforward, because they were deindustrializing and shipping everything out to China and elsewhere. Where do you think that 10% per annum GDP growth went? It went to Europe and to the United States in energy-intensive, highly manufactured products, and with all the shipping and everything else that went with it. So it is quite simple, but you have to measure the right thing. You have to measure carbon consumption. And if you measure carbon consumption, the responsibility of Europe and America and the developed countries is massively higher than currently reported, and our performance is awful. And that's why you see all the Kyoto targets being met and not a blip in the actual growth of the concentration of CO2 in the atmosphere. So it's a relatively simple problem. It's not locational specific. It's a small number of gases, and you should measure carbon consumption. If you don't measure the right things, you'll get the wrong answer. And so we put enormous efforts in Europe into marginally reducing emissions. I'm not saying we shouldn't do that, but if you were really interested in global warming, you do something globally. The 45 gigawatts of new coal in China last year is massively more important than whether you build another wind farm here or not. I'm not saying you shouldn't do that. I'm simply saying you're kidding yourself if you think by decarbonising, say, the English economy, you're going to solve climate change. You really, if you want to decarbonise an economy, you reduce the carbon consumption. And that's why Cameron Hepburn and I proposed carbon border taxes to do the adjustments so that the imported carbon will be accounted into the proper framework. So it's a bit of almost a rant on climate change, but it really is important to get this right and not to live in this world where you think it's all going fine. I'd add one more thing which upset a lot of environmentalists, which I said in my Carbon Crunch book. And I hold this view, and I hold this view in the Burnout book too. There is almost no way that the existing technologies will solve climate change. With another 2 or 3 billion people, with that growth rate and the energy requirements, the idea that wind and current generation solar, plus perhaps some nuclear, could do the job is almost laughable. The numbers just simply don't add up. David Mackay wrote a fantastic book called, I think it was called Sustainability Without the Hot Air, where he did the calculations of the amount of land area, the sheer scale that you need if you're going down the conventional existing renewables to do the decarbonisation, and you work out it can't be done. Now, none of that says you shouldn't do it. It simply says those people who say, oh, you can't have techie solutions. We need technical solutions for climate change. And the good news is that there are enormous potential out there. And of all the technologies to address climate change, the one where most people should spend most of their time looking is in the solar box. And again, the scientists I'm sure here know vastly more about this than I do. But currently we only use, if that's a solar spectrum, a small bit of the solar spectrum. All the rest is out there to be had. And that's where new materials, etc., new ways of doing this start to open up the ultraviolet and particularly the infrared part of the frame. And then the second thing is we need to get new ways of applying it, not rigid panels, although they have a role, but solar film sprayed on everything. Once you start thinking down those routes and you realise that 1 hour sunshine is equal in energy content to the entire world's electricity consumption for a year, you realise there's no shortage of energy. It's just a question of harnessing it. But that's an argument which upsets a lot of people because they've got their subsidies from the existing technologies, they're reaping the benefits of current climate policy, huge amounts of money at stake in these games. That's really challenging to say, spend a little bit less on, say, offshore wind, a few billion less, and a few billion more on R&D as a sensible strategy. That I would advocate very strongly. And in the cost of energy review, which I did for the government in the run-up to at the end of last year, where I identified the legacy costs of the investments we've made so far and how those pan out through time, that's really quite questionable as to whether that has been a sufficient strategy to address the decarbonisation of carbon consumption in this country. Now, if we bring some of these things together, what we're then really interested in is, I'll just skip through to these, what we're really interested in is, you're interested in climate change. For a moment say, I'm interested in natural capital and biodiversity. What's the intersection in the Venn diagram between those two? What should we do which both looks after our natural environment and address the climate at the same time? What's in the junction between those two? And the first thing to say is, not everything is in the intersection. There are some things that are about the natural environment, which you would do on their own right, which have no implications for climate, or very little for carbon, and there are things on the climate change side you might do which have no implications across. Worse, there are quite a few things you do to reduce carbon emissions which might actually damage biodiversity and damage the natural environment. Okay? I'll give you a couple. You might persuade people to drive diesel cars rather than petrol cars. You might take out chunks of delicate landscapes and put intensive renewables upon them. There are quite a number of such areas where there are tensions. You might lose some migratory birds because they happen to go through the path of a substantial wind farm that you want to use offshore for particular purposes. These are not always happy bedfellows. There are trade-offs, and it is not enough to single-mindedly pursue climate policy without ignoring the other dimensions of the natural environment that you wish to take into account at the same time. As I say, there are quite a few examples of policy which go down the road. Biomass is another point. A substantial amount of Britain's corn production is used for bioethanol. Quite a lot of agricultural land is used to produce stuff to burn in power stations rather than to grow crops. These have prices, these have costs, these have trade-offs. And at the moment we have silo policies. We even have environment dealt with in a different department from climate change. Why? Why would you do that? Why would you have these things separate? So we're interested in the intersection. And basically, in the 25-year plan, we're interested in the bits in enhancing our natural environment where carbon is directly involved. Okay? So if you look at the carbon statistics which have just come out for the UK, you will observe that agriculture is responsible for, I think it's about 10% of emissions, something more. And agricultural emissions are not going down at all. Okay, maybe it's even bigger, maybe it's 30%. I can't remember the number off the top of my head. Anyway, it's significant. Okay? And in this context, it's particularly significant since agriculture in this country is 0.7% of GDP. Right? And that's including the fact that half of that 0.75, which is 9 billion, is subsidy. So we spend directly 3 billion, and because they don't pay for the pollution, don't pay for any of the externalities, the effects of the pesticides, the nitrates, every the stuff that goes in the water system, etc., and they're exempt from inheritance tax, and they have cheap diesel, and they don't pay business rates. If you put the whole thing together, about half that 9 billion is actually just subsidy. And by the way, of the 3 billion, 2 and a bit billion, or 2 billion, is just paying them for owning the land. Okay? So if you're looking for areas where you can make cheap, low-cost reductions in carbon emissions, even if you damage the output of agriculture, it's not going to make much difference to the economy, whereas if you do it in certain other areas, it will. Okay? Now, the Climate Change Committee, and this is in my cost of energy review for the government, I looked at how they got to their allocation between the different parts of the economy as to who should do the emissions reduction. And what they don't do is calculate where the marginal cost of the lost output is least important. So if you've got a very unimportant part of the economy, concentrating on that sector is probably economically more sensible than concentrating on the industrial sector, the domestic sector, or even the energy sector. You will have to decarbonise them all in the end, but where you start is probably in agriculture. They don't. Okay? And the really interesting thing about starting with agriculture is that almost all the things you do to reduce carbon emissions from the agriculture sector are good for biodiversity and the natural environment too. In other words, they're a big bit of the intersection of those two bits in that Venn diagram. Why? Because the carbon's in the soil. Okay? And if you deplete the carbon in the soil by the type of intensive agriculture we have, you're probably using an enormous amount of chemicals and other things onto that environment which are doing great damage to the natural environment. I mentioned at the beginning, or somewhere along the line, that I did my thesis on a typewriter. When I was doing my thesis on my typewriter, something else was true. Most people aspired to have cars then. I understand people don't nowadays. But when I drove my car around the summer, the windscreen was entirely splattered with insects. You spent your time cleaning your windscreen of insects. If you drive around a car in Britain, even out in the Cotswolds, you won't have any insects on your windscreen. The devastation that's taken place to for the insect life of our countryside. There's a big study from Germany showing really staggering reductions in insect life. This is all part of making an agriculture chemically intensive, and that has gone alongside with heavy machinery, stripping out the soils, soil loss, etc. So this is a sector where, by reducing the damage to the soils, enhancing the biodiversity in the soils, and controlling the emissions of carbon, quite carefully go together. The second thing you would do in the 25-year plan is you plant a lot more trees. Not for the sake of planting trees. It's not sort of a political competition to see who can plant the most trees. It's because trees have lots and lots of ancillary benefits. So if you want to do flood protection, you should think really hard about your tree population upstream in river catchments. If you want to enhance the well-being of people who live in cities, you should plant trees near cities so people can go and enjoy them and get the economic benefits, the social benefits, the health benefits, the educational benefits, and all the things that go with it. Just like if you're going to have a green belt, have it right next to a city. The last place you should be building houses around Oxford is on its green belt. Now people say, oh, but it's just ghastly agricultural land. Exactly. You should turn it into genuine green land available for people to enjoy. In cities, if you want to do something about air quality, how about the idea that every single street in London should be planted with trees? Most of them would die, but a lot of them wouldn't. And of course you've got to plant the right trees. It's very, very important to get that right. Some trees are better absorbing pollutants than others. But the ancillary benefits to the air quality and the carbon effects, they overlap. And again, that's where you bring the things together. Okay, and then finally, in thinking about the 25-year plan, given we're going to have a lot of climate change, it's quite important to think through how you're going to adapt your landscapes, your countryside, to be resilient against the climate change that takes place. So, for example, are you going to build more seawalls? Or are you going to break seawalls and create wetlands to absorb storm surges? From an environmental point of view, fantastically good thing to do. Okay? If you go to the Essex coast and see where this has been done, if you go to Porlock in Exmoor, you'll see where breaching the seawalls, either by accident or design, creates great habitats and is really good at absorbing the impacts that will come from increases in sea level and the tidal surges and things that go with those things. If you're thinking about the landscape itself, you know, if you're going to have hotter periods, you do not want bare soils. You want to think very carefully about what covers those soils, what vegetation's there, and also what its carbon content is. And, I mean, it's probably not true, but for those who really want some interesting bedtime reading, if you read Farmers Weekly, you will discover that the current concern is that our soils have, quote, 10 years left in them. You see the speed with which the soils are being depleted. Well, again, under climate change, these things are going to get worse. Therefore, you think about how you protect those soils, and most of the things you protect to protect those soils improve the natural environment and take that forward. So lots of stuff in the overlap in practical policy terms between what we're trying to do in the 25-year plan to meet that overarching objective of leaving the natural environment in a better state, and what we're trying to do on the climate change side. And the interface that really matters is not the electricity sector and the energy sector, it's agriculture, land use, and the way that operates. And there are huge opportunities to do really small-scale practical stuff. There are things that we must stop happening, like destroying green belts and green spaces near to populations, and there's no great economic loss in concentrating on agriculture, A, because the current form of agriculture is unsustainable, and B, if the output drops in terms of economic value, well, hey, it's a very small part of GDP and employs very few people compared with the benefits that come from the natural capital side. So let me draw that together. What I've tried to do is open on the horizon. So there's a silo called looking at climate change. There's been a whole silo looking at protecting the natural environment. Actually, these are twin problems that confront us in very large scale, globally and locally. The problems are different. Climate change is, quote, easy. Small number of gases, doesn't matter on location. Natural environment, extremely complicated, extremely locational dependent, and has an enormous complexity associated with it. The intersection between those two is many and various. There are a lot of climate change policies which can do damage to the natural environment, and some don't. They're trade-offs, but there's a big intersection in between, and that's our natural landscape, our natural environment, and there are lots of stuff we can do there, which is a good thing to do in its own right. It's good for the natural environment, and it's excellent for finding a cheap way of reducing some carbon emissions in the bigger picture of trying to reduce them all. I hope that's been of interest.